Welcome to Homework Help for Lesson 6.4, our word problems lesson. Today we're going to do problems from the homework from numbers 1, 3, and 4. But first, we're going to start with some notes from page 7. So, go to page 7 in your tan book, or you can just take these notes separately on a sheet of paper. This is essential to understand these two formulas and how to plug in for each variable. So we have our first formula, usually used for compound interest. I'm going to call this formula number 1. So usually when we're talking about compound interest, we're referencing money, right? You put money in the bank or you invest money and you're hoping that your money will grow. Well, this is the formula that we use to see how much your money changes over time. It looks a little crazy, but really all it is we're plugging stuff in. So we need to know what's A represent, what's P, what's R, and N. So here's the information you need on the left side. A represents the final amount. So we're talking at the end of the growth period, like how much money did you end up with? P means the principal. Principal is just a fancy way of saying your starting amount or your initial amount. R refers to the interest rate, the rate at which your money is growing. N means the number of times that your money is compounded per year. This is really important, per year. Okay, the number of times it's compounded per year. And T is the length of time. T is always measured in years. So let's have a quick look over here. Let's practice how we're going to plug in for R, for example, when we talk about the interest rate. Let's say you're reading a problem that says, hey, the interest rate is 9%. You need to understand that we are not going to be writing R equals 9. We have to actually express the interest rate as a decimal. So express in decimal form. So 9% as a decimal is actually 0.09, and that's what I'm going to plug in for R. Let me write that over here. R equals 0.09. So you might say, Ms. Nami, how did you get that? Well, one surefire way is just take the decimal point, which in this case it's 9, so it's 9.0. Like the decimal's after the number, and you always move it back 2 places. 1, 2. Drop it there. Since there's a gap here, I'm going to fill it with a 0, and that's how I got 0.09 or 0.09. Okay, now you need to be careful. If you don't move the decimal the right amount of places, if you, let's say, only move it 1 spot and you say 0.9, that's incorrect. That represents 90%. 0.9 is 90 out of 100. So please make sure you're moving the decimal 2 spots over. I'm going to rewrite that. So 9%, you take your decimal, boom, boom, drop it. That's 0.09. Let's do it again. If I say 12% is the interest rate, you're going to drop the decimal, move it back 2 places. So in your equation, you're going to plug in 0.12 or 0.12. They're the same. Next, let's say it's 4.6%. Try it yourself. See if you get the right answer. Go to the decimal. This time we have one. Move it back 1 spot, 2 spots, drop it. And if there's a gap, you're filling it in with a 0. So here I'm going to plug in 0.046. That represents 4.6%. Okay, with our 2%, move it back 2. That represents 0.02. Whereas 20% is actually 0.2 or 0.20, which are the same. And then finally, let's go with a really small decimal. If it's 0.6%, you've got to get rid of that percent sign by moving back 2 places. So this one, we fill in with a 0, is going to be 0.006 or 0.006. And that's less than 1%. So let's say somebody had accidentally written 0.6 as their actual decimal. They've actually represented 6 60%. Or let's say someone accidentally wrote 0.06. Well, they've represented 6%. So please keep in mind, you're going to have to be very careful moving from percent to decimal format. Okay, the next thing that might give people a little trouble from this first formula is the n, which I've highlighted in purple, or now in blue. And n represents the number of times you're compounding interest per year. So if I say, hey, it's going to be compounded semi-annually. Well, semi-annually means 2 times per year, so I'll set n equal to 2. If we say quarterly, that's 4 times per year, so n is equal to 4. You really have to memorize these words and what they mean. Monthly, that's 12 times per year, so n equals 12. There are 52 weeks in the year, so if I compound every week, that's 52 times per year. And then if we compound daily, then we're saying n equals 356. So keep these notes in mind when you're plugging in to the first formula. Now the second formula is actually it's really nice because there's less stuff going on. So formula 2, you're going to use anytime you see the word annual growth or decay, or if you don't see any word at all. So if it just says, hey, the population grows at a rate of 15%, and it doesn't say annually or semi-annually or quarterly, it doesn't say how often, then you're always going to use this second formula. So for this one, all we need to plug in is for A, P, and R. Oh, and then I forgot, the last variable is T as well. So how much time has passed. So it'll become fairly obvious to us when to use formula 1 with our compounding and when to use formula 2, which has to do with annual growth. All right, let's jump into some notes from page 7. So example 1A says, so you invest a principal, or remember, a starting amount of $200. The interest rate is 9%. You invest it over 4 months and you compound monthly. So the first thing I want to do is say there's a typo here. We're going to erase the word months and we're going to write years instead. Let's say we're investing this over 4 years. Okay, so in order to use our formula, we're going to need to plug in for P, R, N, and T. The reason we're not plugging in for A is because the question is asking what is the final amount. So that means that's what I have to solve for. So if I have to solve for A, then I'm just going to write A equals and then plug in everything on the right. So my principal is 200. So instead of P, I'm going to start with 200. Parentheses, we're just going to plug in as we go. 1 plus. Now I have to plug in my rate. So if it says 9%, we have to convert that to decimal form. That's really 0.09 divided by N. N means the number of times per year. So we need to figure out how many times it's being compounded every year. Well, since being compounded monthly, that means N equals 12. So 12 is in my denominator. Now in the exponent, I need N times T. N I already know is 12. We just discussed that. And then T is how long it's stored in years. So since we changed the question to be 4 years, that means T just equals 4. And they multiply together. So I've plugged in all of my variables. Now I just need to use a calculator to solve. So I'm going to pull up a calculator and solve it alongside you. So I'm going to plug it in exactly as I see. It says 200 parentheses 1 plus 0.09 divided by 12, close parentheses, to the power of 12 times 4. So I'm just going to write 48 because 12 times 4 is 48. Enter. And this is what I came up with. $286.28. So approximately $286.28 would represent my final amount. So one quick and easy way to check that you did this correctly is just to make sure whenever you're talking about investing money and earning interest, well, that means that your money should grow. So we want to make sure that our final amount really is bigger than our principal. So it is. It grew by $86. As long as it didn't shrink, we can say, okay, that's a reasonable answer. I can be confident that I didn't make a mistake. All right, let's do example 1b. So example 1b says, now we're investing $200 at 11% for 4 years, and we're compounding yearly. So before we plug into our problem, let's just try to identify all the variables. Okay, let's look over here at our formula. So A is what we need to solve for. We're going to leave that blank. P is going to represent 200. Our rate, it says right here, our rate is 11%. So that means we're going to actually move the decimal over 2 spots. We're dealing with 0.11. N, the number of times per year. Well, the number of times is compounded per year. This one says it's compounded yearly. Well, if it's compounded yearly, that means it's just being compounded 1 time per year. So N is equal to 1. So that takes care of N here and here. And the last thing I need to take care of is T, the number of years. And T says it's equal to 4 years. So I'm confident that I have all of my variables assigned. I just need to plug them in now. So let's do it. A equals P, which is 200, parentheses 1 plus R, which is 0.11, divided by N. Well, we said N is equal to 1 because it's compounded yearly, once per year, to the power of N, which is 1, times T, which is 4. So let me rewrite this really quick. This guy, 0.11 divided by 1, is really just going to be 1 plus 0.11. And then 1 times 4 is really just 4. So I want you to notice something interesting that happened here. Remember how in the beginning I said there's a second formula? And we use that second formula anytime we discuss annual growth and decay. Look at what the formula says. P 1 plus or minus R to the T. Let me write that here really quick. P1 plus or minus, and in this case we're going to use plus because we're growing our money. So if I had just plugged into the second formula to begin with, I would actually end up exactly where I'm at because N was 1. So this denominator really disappeared, and T times 1 is just T. So whenever you see annual, you can just jump straight into the second formula whenever it's compounded yearly or annually, once per year. All you have to do is plug in your P, plug in your R, and plug in the number of years. So we're going to just plug this into our calculator and finish the problem. So I want to see what A equals. It says 200 parentheses 1 plus 0.11 to the power of 4. And I get $303.61. $303.61. Don't forget the dollar sign. Okay. Next problem from the notes is example 2. All right, example 2 says, in 2001, the population of wolves was 234. The growth rate is 0.15. What will the population be in 2017? So we're not being told what P is. We're not being told what R is explicitly. We actually have to read the question and identify from the word problem all of our variables. So it says the population of wolves in 2001 was 234. That's their way of telling you the starting amount is 234. So that's going to be my P because it's my initial amount. Now it says the growth rate is 0.15. Well, whenever we talk about rate, we're describing R. And notice it's already in decimal format. There's no percent there. So R is just going to equal 0.15. What will the population of wolves be in 2017? So here, very indirectly, they're actually discussing time. If in 2001 is when we start, then how many wolves will there be in 2017? Well, that means that the number of years that have passed from 2001 to 2017 is 16. They're basically saying after 16 years, how many wolves do you have? So anytime they're asking us about the population or the amount of money after some number of years, that means we need to solve for A. That's what we're looking for. But the question is, which formula are we going to use? Are we going to use Formula 1 or are we going to use Formula 2? Well, notice if you're reading the question, we don't see anything about the word compounding. We don't see compounding quarterly or annually or even weekly, none of those. So even if we really wanted to, we wouldn't be able to find a value for n. It doesn't tell us how many times this is compounding. And in fact, the way that populations work is we're going to always use the second formula. Whenever you're missing the information you need about compounding, you're just going to jump to the second formula. There is no n here after all. So let's plug in our three variables. A equals P, which is 234, times 1. Now, since this is growing, I'm going to use a plus sign. The minus sign, by the way, is when you're decaying. Or let's say the population was falling. Okay. 1 plus, and then the growth rate is 0.15, and I'm taking that over 16 years. Let's plug it in and see what we get using our calculator. So 234, parentheses, 1 plus 0.15, close parentheses, to the power of 16. You really should practice, by the way, doing this in your calculator. Everyone's calculator is different, so get used to using yours so that on the test you feel comfortable. So it looks like our population after 16 years in 2017 is going to be 2,000. Wow, that's crazy. 189.68. Well, we're talking about wolves here. I can't have 0.68 of a wolf, so I'm just going to round that up to 2,190 wolves, approximately, in 2017. Okay, so let's go now into our homework problems. Number 1A. Says find A, or the amount of money that you have after you've invested for T years. What's nice about this problem is they kind of give us the numbers and the letters right away. We don't have to scan the word problem for it. But we do have to decide which equation we're going to use. Okay, Formula 1 or Formula 2. So let's see. We got P, we got a rate, let's change this, by the way. Our rate, what should we rewrite it as? Boom, boom, 0.12. We got T already written in years, which is good. Oh, and it's being compounded quarterly. Since we're compounding quarterly and not annually, we will not be using Formula 2. We're going to be plugging in n equals 4 times per year. Remember, how many times you compound per year is represented as n. Since we're compounding quarterly, that's 4 times per year. So that's what I'm going to plug in here and here. All right, let's do it. So A equals, my principal is 25. 1 plus 0.12, that's R, over compounding quarterly, that's 4 times per year, to the power of 4 times T. What's T? T is 6. Now is the time to use our calculadora, the Explorer, in order to, in order to see what our final amount is. Okay, go ahead and plug it in with me. We got 25 parentheses, 1 plus 0.12 divided by 4, close parentheses, to the power of 4 times 6 is 24. So I'm just going to write it. Woo! Looks like we're going to make $50 and approximately 82 cents. Not so bad. I mean, you money like more than doubled. Remember, you started with 25 and we ended with 50, almost 51 bucks. Now, yeah, it did take 6 years, but you know, better than nothing. All right, let's try the second one. Problem number 1B says you're taking $200 now. So that's P. Check mark, we got P down. You're investing it at a rate of 6.5%. Let's write that in decimal format. Take this decimal, move it over 2 spots, fill in the blank. So that's 0.065. So we got R. Next, T is 3 years. Okay, so T is equal to 3, got that. And it's being compounded annually. It's being compounded annually. That means that n equals 1. So you could use this formula and use n equal to 1, or recognize that r divided by 1 is just r, and 1 times t is just t. Remember, when it says annually, you can just go straight to the second formula. So our formula is going to look like this. A equals P 200, parentheses 1, it's growing, so we're going to use a plus sign. Our rate is 0.065 divided by, wait, I forgot we're not doing that one. 0.065 to the power of t, 3 years. You might be saying, Ms. Name, what if I want to use the first formula? Okay, I'm going to show it to you. You would have A equals 200 and then parentheses 1 plus R, which is 0.065, divided by N, which is 1 time per year, to the power of 1 times T, which is 3. So now convince yourself that the left side is actually the same as the right side. 0.065 divided by 1 is the same as 0.065, and 3 times 1 is the same as 3. So I'm just going to assume that from now on when it says annually, we're just going to jump straight to formula 2. Let's plug it in the calculator, see what we get. So what does our $200 grow to? Well, if it's growing at a rate of 6.5% or 0.065, and it's growing for 3 years, and it's growing for 3 years, we are going to end up with a nice, cool $241 and 59 cents. So notice that really the bulk of this work is just identifying letters, choosing a formula, and then it's just calculator work. We're just plugging stuff in. This is not really too much thinking going on. So hopefully you feel a little more comfortable. Let's try this last problem. Okay, we have a word problem, so we need to scan, we need to identify our letters. Let's see how many we can get. You buy a vehicle and take out a loan for $35,000. If the loan has 4.2% interest compounded monthly and you expect to repay it in 5 years, how much will you have actually paid for the vehicle? So scanning it one more time, let's see what we recognize. This is an amount of money. Okay, right now I'm not sure if it's the total, if it's the initial or the final, and it's not a big deal. We'll come back to it. This over here is definitely my rate, so let's write it in. R equals, moving the decimal over 2 spots, we get 0.042. Ooh, it says compounded monthly, so I know that's my N. The number of times I compound per year is going to be 12. I expect to repay it in 5 years. Well, that must be T, the amount of time that's passed in years. How much will you have actually paid for the vehicle? So if I took out a loan for $35,000, but then I have to pay interest on that loan, then that means at the end of the 5 years, I'm actually going to pay back that $35,000 initial amount plus all the interest. So that means that this $35,000 is the initial. And the amount, how much that I'm trying to answer, is the after, or the final amount. So since I know the initial, that means I know that the principal is actually $35,000. And A is what I'm trying to solve for. Okay. So let's see, which formula are we going to use? The one on the left, formula 1, the one that has compounding, or the one on the right that is annual? Well, since we have an N, we're going to definitely use the one on the left so that we can plug it in here and here. So let's do it. A equals, my principal is $35,000. That's my starting amount. 1 plus my rate is 0.042. We already converted it to decimal format, so good for us. Divided by the number of times compounded per year, 12 times per year. To the power of N times T, so that's 12 times T, which is the number of years, that's 5 years. Sweet. We're going to plug it in now to our calculadora. Come on. Okay. $35,000, parentheses, 1 plus 0.042 divided by 12 to the power of 12 times 5. Let's see. I'm just going to write it in. 12 times, ooh, look what happened. That 5 is no longer part of my exponent. So I need to go back and make sure that that 5 is being multiplied in the exponent with a 12. So clear. Instead of writing 12 times 5, the calculator doesn't seem to want to do that. I'm just going to write 60 right away. Oh my gosh, this is crazy. If you take out a loan at 4.2% interest, compounded monthly, and paid over 5 years, you're actually going to end up paying $43,000, $43,162.90. Wow. Think about that for a quick second. The loan you took out was only for $35,000, but there's a really steep price to borrowing money. And in this case, the extra amount you had to pay just to borrow that money is the difference between $35,000 and $43,000. You're actually paying a total of $8,162.90 in interest alone. So think twice before taking out a loan, but also, sometimes you got to do what you got to do. Got to get around. Okay, so that was the answer. Oh, we have one more. Dang, I thought we were done. Okay, number 4. Har. It says in 1995, the population of the U.S. was 263.2 million. Our growth rate is 0.7%. So what's the population in the year 2000? So this 263.2 million was our starting amount or our final amount? Well, since it was in the year 1995, this has to be our initial or our principal. We started at 263 million. Now the growth rate is 0.7%, so that's R right there. That's R equals. See if you can get it right. Move the decimal over. Once, twice, you should have got 0.007. 1, 2. Drop the decimal, fill in with the 0. See how I did that? Okay, and then it says, what's the population in the year 2000? So that's an indirect way of telling you how much time has passed. So that means the number of years that have passed since 1995 till 2000 is actually 5 years. Since it's saying what's the population, that means that they want to know the final amount. So we need to solve for A. Are we going to use Formula 1 or Formula 2? Formula 1 we need to see the word compounding. Since I don't see that word here, there is no N. So I'm just going to jump into Formula 2, which is A equals P1 plus R to the power of T. I just use the plus sign because it says it's a growth rate. So I'm adding on each year. All right, let's plug it in. A equals, our principal was 263.2. 1 plus our rate is 0.007. And we're doing this over how many years? From 1995 to 2000. We said that was 5 years for T. Using my handy dandy calculator, I am going to plug it in and let's see if we get the same answer. So we're answering in millions. So we got 263.2 parentheses 1 plus 0.007 close parentheses to the power of 5 years. Woo! Our population over 5 years swells to a cool 272.54 million. Don't forget the units. We're talking in millions here. Million people in the U.S. in the year 2000. So that concludes our lesson for today. I hope it was helpful for you. And I'll see you next time.